All right, gang. So we have been talking a lot about projectile motion, and what I want to do here is go over how to do some of these horizontal projectile problems. So in this example, what we're going to do is we're going to have a cannon that's sitting on top of a cliff, and it shoots a cannonball horizontally at 20 meters per second. Now, if the cliff is 20 meters tall, what we want to find are two things. We want to first see how long is the cannonball going to be in the air, and second, where is it going to hit the ground? So let's kind of break this down a little bit. And I know we've done a lot of problem solving in this class, but I just want to kind of walk through how I think through these kind of problems. So first of all, if we've got a cannonball that's shooting or if we have a cannon that's shooting a cannonball horizontally at 20 meters per second, and if the cliff is 80 meters tall, what do we know? Well, obviously we know a few things right off the bat, but there's also some things in here that it assumes that we know. First thing I want to talk about is that, we've been talking about projectile motion, and we've been talking about those horizontal and vertical components. Now we know that those are independent, okay? When something is falling through the air, it has a horizontal component that's completely independent of the vertical component. But there are some things that are related to both of those, and time is one of those things that stays the same in both. Just like what we saw in the Mythbusters video, where the dropped bullet and the fired bullet both hit the ground at the same time when they're fired, or when they're dropped and fired from the same height. Okay, that is going to be really important. But like I said, let's kind of go over some other things that we know now. Obviously, we know that the velocity is 20 meters per second. But think about this: it's shooting out of that cannon, so that velocity is in the x direction. So we know that the velocity in the x direction is going to be 20 meters per second. We also know that the cliff is 80 meters tall, so that's going to be 80 meters. So we can say the height, or we could say it's the distance. That's going to be 80 meters. Another thing that it just kind of assumes that we know is that this ball, or this cannonball, is flying through the air and it's accelerating due to gravity. So remember that baby G is 10 meters per second. Now this is going to be really important as we kind of work through this. So the question now is, okay, we know all this stuff, but how long is the cannonball in the air? And second, where does it hit the ground? So let's kind of think about what it is we're trying to find. Now, so on the first one, how long is the cannonball in the air? This is talking about time. So for number one, we're trying to figure out what is the time that this is going to be in the air. For the second one, okay, where will it hit the ground? Well, think about where the ground is. So it's going to hit somewhere right along here, along the bottom. Well, that's in the horizontal. So what we want to do here is find the distance in the horizontal, or distance along the x-axis. So in the first one, we're trying to solve for time. Second one, we're trying to solve for distance along the x-axis. Now that we know what we're trying to find, let's think about which equations we're gonna use. Now, for the first one, for how long is the cannonball in the air, and we're kind of searching for time, what we're doing is we're looking for an equation with time in it. Now, I haven't given you any equations that solve directly for time, but we do have some that we can manipulate. Now, the trick is going to be to find one where the time is the only unknown. So I think about this one right here. So distance equals 1/2 acceleration due to gravity times time. So remember, the time that it takes for it to drop is the same as the time that it takes to go like that. So we can use that idea to help us with figuring out which we're going to use. So distance is going to be 1/2 acceleration due to gravity times the time squared. But once again, the idea is that we have to solve for time. So if I'm going to do that, okay, so I'm just going to write this over here. So distance is equal to 1/2 acceleration due to gravity times time. I want to get time all by itself here, so I'm going to divide each side by 1/2 baby g, so that cancels out, so divide by 1/2 baby g, and you know dividing by 1/2 is the same as multiplying by 2, so I'm just going to do that. And also we've got time, we have time right over here, and we want to get that by itself, so if time is squared, the way we get that is by taking the square root of both sides. Man, that's messy. So let me just rewrite this. So what we know is that the square root of 2 times the distance divided by acceleration due to gravity is equal to time. Okay, so that's what we're going to use for the first one. Now let me erase all of this stuff. Let me get this out of the way for you so we can. All right, good enough, I guess. Okay, so the next one, for where it's going to hit the ground, remember we're looking for distance, but remember this has to be distance that's in the x direction, so along the ground. Now, we have to remember, okay, we're not dealing with acceleration due to gravity. But, the other thing is we're talking about something that's moving along at a constant velocity. So think back, way back to the beginning of the year when we were talking about that constant velocity model. And we know that velocity equals distance divided by time. Okay, so distance is what we're looking for. So what we want to do is just solve for distance. Well, velocity equals distance by times, or if velocity equals distance divided by time, I'm just going to go and multiply each side by time. So then these cancel out, and I'm left with distance equaling velocity times time. So we're going to use that for the second one. But one thing I want to talk about really quick is this one right here. Some people, when they've tried to do this, they're saying, well, why don't we use the velocity final equals gravity times time? So think about that, okay? First of all, it does have time in it, but even though it has time in it, and we know what acceleration due to gravity is, do we know what the final velocity is? Do we know what it is, or how fast it's traveling when it hits the ground? And we don't. So that would leave us with 2 of these unknowns. So we can't use that one. The other one is this one right here. The distance equals the initial velocity minus 1/2 acceleration due to gravity times time squared. The reason that one doesn't work for our distance is because what we're doing here is we're talking about weight. That would work. We can use both of those. But anyways, distance equals velocity times time was a lot simpler. Sorry, led you down the wrong track there. All right, so now let's get into this. Let's solve this. So let's look at the first one, the how long is the cannonball in the air. So we're going to solve for this. So we have, once again, the cannon shoots a cannonball horizontally at 20 meters per second. If the cliff's 80 meters tall, how long is the cannonball in the air? We talked about a few things already. So first of all, we're looking for time. That's our unknown. We know that acceleration due to gravity is 10 meters per second squared. We also know that distance is equal to 80 meters. So let's use that. We decided that the equation was going to be time is equal to the square root of 2 times distance divided by acceleration due to gravity. So now we just go ahead and start plugging things in. So 2 times distance, so that's 80 meters divided by acceleration due to gravity, 10 meters per second squared. Okay, so I go 2 times 80, 160. 160 divided by 10, that's 16. Square root of 16, that would be 4. So our answer is, it is in the air for 4 seconds. Easy enough. All right, now the second one. Okay, where will it hit the ground? So remember, we're talking about where along this x-axis is it going to hit the ground. And we went through and we decided that we are trying to find distance in the x. Okay, we know that the velocity is equal to 20 meters per second. We figured out, because I had a little aha moment, that there's two things that we could actually use. But we're going to go the easy route, because we are going to say, oh, we also know that time from the last one is equal to 4 seconds. So we know that distance equals velocity times time. So I just go ahead, put that in here. Distance, velocity, 20 meters per second times time, which is 4 seconds. So we have a distance of equaling 80 meters. All right, well, I hope that helps kind of show you how to work through these problems. Now, there's going to be some slight twists on the practice problems that you're going to do, where you might need to solve for different things, but the main idea is the same. So, as always, let me know if you have any questions.